I forgot to mention this by far so far, but Janus is completely open source, so you can just go to the GitHub repo, clone it, and do whatever you want with it. We have also some demos that you can play with on a website, so you just go there, play a bit with the available demos that show you the different things that you might do with Janus, so just a limited set of examples. And we also have a quite active community on the Google Group stuff where a lot of people interact with each other in order to, let's say, try and discuss possible ways of overcoming some troubles they are having, or let's say proposing new ideas and things like this. So if you're interested, I really encourage you to have a look at all these links and engage with us in the community. So just to explain you a bit how the architecture was conceived, we tried to conceive some kind of a modular architecture. So, and we had, of course, several examples for this. We had worked with Asterisk a long time. We had worked with the media control specification in the ITF with a long time. All of these things gave us such kind of an idea to have some kind of a modular architecture for Janus as well. And more in particular, we have the core itself, the core of Janus that only, let's say, implements the WebRTC stack. So all the protocols that I showed you in the slide before, which means taking care of the signaling, the negotiation, all the ICE, the SRTP stuff and things like that. And the core is mostly responsible for that. Then, of course, we have some additional plugins, modules that allow us to, let's say, interact with, that allow people to interact with Janus, because, of course, you have a component and you want to be able to talk to it, to interact with it, and to control it. And this is done via what we call the Janus API, which is a protocol that we conceived ourselves. And you can use this Janus API over different protocols. Namely, you can use it over a simple HTTP using a REST API or WebSockets, and recently also on new innovative protocols like RabbitMQ, Unix sockets, and even MQTT, which is an interesting protocol because it opens more options for the IoT, the Internet of Things kind of world, where it's really very used. So this is additional kind of plugins that you can just plug so that you can add, let's say, a new transport in the future for Janus without having to rewrite anything from scratch. And more interestingly, all the application logic, so what you are going to do with the media that is coming from users and what you want to send to users is not done within the core, so it's not baked in the core, but it's done in other application plugins, which are basically what provide you with all the functionality that I'm going to describe you. So we have, for instance, as I said, users attached to plugins via the Janus core in general, so using one of the transports you see there. Then these plugins allow you to, let's say, identify some of the users that you have. The core handles all the WebRTC stuff, so the plugins don't really have to worry about the WebRTC detail. The core takes care of that. And then in general, all the plugins decide how you want to route and manipulate the media that is resulting of this communication. And so we have some example plugins there. So you have a simple echo test plugin, which, as you can guess, just you connect to the echo test plugin, whatever you send, you receive back. We have a streaming plugin that allows you to restream whatever kind of plain RTP source that is not WebRTC based and translate this to a broadcast that can be sent to a lot of participants at the same time. We have a video room plugin, which is pretty much like a selective forwarding unit, pretty much as the media subcomponent that Iñaki described yesterday. We have, of course, also a SIP gateway, which may be more of interest to you, and I'll spend some more words on this later. And we have other plugins as well. And the idea is that you can combine all of these plugins in creative ways in order to implement new nice applications. And I'll also try to describe this in a few words later. This is an example, this is a diagram that explains a bit how this all works in practice. So let's say you have a browser that is talking to Janus in order to participate in some kind of multimedia application. The way that the users interact with the core is typically using one of the transport protocols. Let's say they are using HTTP and the Janus API on top of that. And as part of that interaction, this may result in the creation of one or more peer connections, whereby peer connection you can assume is just, each peer connection is associated to an SDP of fair answer, basically. So you can assume it's pretty much like a SIP session. So you have separate SIP sessions all associated with the same user. And all these sessions then can actually be attached to different plugins in the backend, which means that then you can create creative applications by just combining, let's say, the SIP plugin, the video room plugin, the streaming plugin together in order to create something that the individual plugins could not create. And all of this is made possible, of course, by the fact that the Janus API itself is conceived to be modular, because, of course, each plugin has its own requirements, which means that each plugin talks its own language. So if you want to create your own plugin for Janus, you'll probably want to be able to talk to the user about some things that are of interest to your specific plugin. And the Janus API makes this possible because the Janus API, whenever the user wants to talk to the plugin and they interact with each other via requests, responses, notifications, or whatever, then in this case, the Janus API acts like an application-level transport. So it doesn't really care about what is carried within the payloads. It's just, let's say, an opaque payload that whatever you send through there is a message that is then passed transparently to the plugin so that you can interact and do whatever you want with the plugin, which makes this kind of approach really powerful, because in this case, you can really just write a new plugin tomorrow, attach it to an existing Janus instance, and you add a completely new feature that Janus didn't have before without really having to re-implement Janus from scratch. You just created a new plugin that allows you to do many new things in your own applications. And just to give you a few ideas of how you can actually deploy Janus in the wild, these are just an example of a few topologies that you could use. The simplest one is, of course, the same that I was describing in this slide here. So you have a browser talking to Janus directly. So you can assume, for instance, that you are using HTTPS or secure WebSockets to talk to a Janus instance somewhere. So you have your own web application on Apache, HTTPD, for instance, or Nginx, or whatever it is. And via JavaScript, you tell the user to connect to Janus directly. You exchange messages with Janus, and this results in the creation of the peer connections that I was saying. So this results in the creation of the multimedia sessions that the users and Janus can have. But the more interesting use case is typically having some kind of a proxy in between the users and Janus, mostly, if not just for security reasons, because in this case, you can just, let's say, worry about the establishment of secure HTTPS or WebSockets within the proxy, which can be Nginx, for instance, and then just relay the packets exactly as they are via HTTP or WebSockets to a Janus instance. You can also decide, for instance, to have the proxy handle multiple Janus instances. So you say, for instance, /Janus1, a request going to /Janus1 will be forwarded to one of the Janus instances that you have. A request to /Janus2 will be sent to another Janus instance that you have, and you can, let's say, have a proxy handle multiple Janus instances in the backend without having to, let's say, share too many URIs or things like this. At the same time, you can also, let's say, decide to have each Janus user be handled by a single proxy, or more interestingly, and this is something that a lot of companies are doing recently, is, let's say, wrap the Janus API within an application, which can be a Node.js application, a Java servlet application, whatever kind of server-side technology that allows you to, let's say, implement some protocols on the back end. You can assume that you can, let's say, handle all the Janus API interactions, so as far as signaling and negotiation is concerned, within your own application server, and then expose your own API to users, so that users don't even have to know or implement the Janus API. They just talk whatever API you are using, let's say, right now, or you want to your users to use maybe a simplified API that is specific to the scenario that you are working on. And then these interactions between your users and your application are translated to requests to Janus in the backend, which means that you have complete control over how you actually use a Janus instance. You can decide who can create rooms, who can, let's say, join a conference room, how you want to create a new stream, how you want to handle your SIP users, and so on, which gives you complete control and which is typically desirable by most companies. At the same time, of course, you can also make the management of multiple instances transparent to the user, because in this case, you can have all your users point to a single application, and then the application transparently decides which Janus will be used for a specific feature, for instance, which is kind of interesting. Or you can make this even more dynamic by having, let's say, multiple wrappers of Janus that are managed by some kind of a media resource broker, so that you can dynamically decide which wrappers are going to be used, so that you can scale even more and things like this. So these are just some rough examples of how you can actually deploy Janus in the wild, but these are typically the most common approaches. And what I want to stress out is that I mentioned the fact that in Janus we have plugins handling the application logic. So we made the example, for instance, of EcoTest, SIP gateway, selective forwarding unit, and things like this. But what I really want to stress out is that all those plugins are not to be conceived as applications. So the SFU is not just the conferencing plugin, for instance. We just see them as features, so bricks that you can put together in order to build, let's say, a much more complex house, so a much more complex application. So you can, let's say, combine them in creative ways in order to, let's say, use individual features, which individually would be quite simple, and create something much more complex and interesting out of this. And there are really a lot of examples that we could make. I'll try to make, I will not linger on these very slides just because I have a couple of graphic images that describe this better and some examples later on as well. But really this opens a wide, really a wide room for creativity and things like this. A very simple example, for instance, is some kind of a webinar. So let's say you want to present a webinar online to a lot of people. What you can do is prepare some kind of web-based application where you can, let's say, capture your screen using and spread it around using the video SFU, because you just capture your stream, send it to Janus once, and everybody that is interested is going to receive it. Do pretty much the same for video as well. And then at the same time, maybe for audio, use a different approach. So maybe use some kind of the conferencing audio plugin that we have, or even, let's say, using SIP just for audio, so that you can allow, for instance, people from the phone to actually interact with your WebRTC users to make questions and things like this. And this is really a very basic example of how you can combine at least 2 different plugins to make something. And this is another example that shows how 2 plugins can interact with each other, which is the social TV, which is, let's say that you want to watch a football match with your friends, everybody at their own home. What you can do is basically use the streaming plugin to make sure that the match is streamed in real time to all of you, so wherever you are. And this can be done via the streaming plugin because maybe the capture of the TV, of course in a legal way, is done, let's say, via a way that is not WebRTC compliant. So you inject it in Janus, and Janus turns it into a WebRTC broadcast. And associated to that, you have a small conference room that allows you and your friends to interact with each other and watch the match together. So that if somebody scores and you're all happy together, you can just do that basically. And this is really a very simple example and something that I can also show a demo to interested people later on if you want. And another interesting aspect is that, of course, Janus is a complex component, and especially when WebRTC is involved, WebRTC peer connections are involved, there are several things that can go wrong. So one way by which you can check what is going on, so for instance, a WebRTC peer connection that is not working, somebody that fails to send or receive their media for some reason, and so on, what you can use is what we call the admin API, which is basically a separate API from the Janus API that allows you to handle some administrative tasks. So you can use it to send requests to inspect the status of a specific peer connection, for instance, or also to manipulate some properties, enable some more debugging and things like this. And at that link over there, you can see there is a small guide that I prepared in order to demonstrate to interested people how exactly the Janus API, the admin API can be used in order to figure out why something is wrong with a specific session, for instance. So if you're interested, you can have a look at that and it tries to explain it in a clear way. So I talked a lot about WebRTC in general, but you may be more interested, let's say, in the SIP aspects related to all of this, and especially how this can be of help within a SIP infrastructure, for instance, and more specifically, whether or not Janus can be used as a way to allow WebRTC users to interact with your pre-existing SIP infrastructure as it is. And the idea is that, of course, it should. It can do that, and we do that in our own use cases as well. And we have a Janus plugin that is specifically devoted just to that. And we have also a demo over there if you want to play with it a bit. And the way that it works is that it's basically a WebRTC to SIP gateway, and more specifically, of course, it allows you to handle WebRTC on one end and SIP on the other. And the way that it works is basically the Janus SIP plugin acts on a SIP endpoint on behalf of the WebRTC user, which means that the WebRTC users do not talk SIP in the browser. So you do not have to have a SIP stack in the browser, use WebSockets to talk to it and things like that. You just use a very simple protocol between the users and Janus. So something that just says, okay, call this SIP URI, accept this call, nothing more than that. It's the SIP plugin that actually implements a SIP stack within the plugin itself, and so takes care of all the SIP complexity, managing the SIP state, and so on. And whenever something relevant happens, so if, let's say, there is an incoming call, if somebody accepted your call and things like this translates to events that are sent via JSON to the user in the application, which means it's quite easy for web developers to use because they really don't have to understand anything about SIP itself. They just have to know, for instance, that there are concepts like CPU arrays that you can interact with in order to do something, and it's really quite easy. We have some ways to manipulate the SIP session if you're interested in some specific features. Let's say injecting some very specific SIP headers if you're interested in having some, if your own application, for instance, uses some headers that the SIP endpoint needs to provide, but in general, it's really just as easy as it is. Which can not always be what you might want, of course, because sometimes you really want to have a complete control and access over the whole SIP stack and SIP management. So you may actually want to have your own SIP stack within your own application for some reason. And as I was saying, the SIP plugin doesn't really allow for that right now, because we really try to hide all the complexities of the SIP stuff to the user. We do completely all of that within the plugin for several reasons, and it has worked fine for us. But of course, as I was saying, Janus is really modular. You can just write a new plugin for that if you're interested in stuff like this. And in fact, this is something that Saul and I have been talking for a while recently. So the idea of having just a new plugin that just takes care of the setup of let's say, multimedia sessions without delving into the details of also the signaling stuff. So the idea is to just create something that allows you to exchange SDPs that take care of the translation. So the management in the WebRTC gateway that I showed at the very beginning. So something that allows you to use the WebRTC version of RTP on one end and the SIP version of RTP on the other, and then you receive this new formatted SDP and you can use it within your own SIP messaging out there. So this isn't something that exists yet, but I plan to, let's say, to work on it soon. And another interesting thing, especially with respect to the SIP interaction, is that recently we've also started working together with Homer and HEP on the possibility of let's say, adding Janus-originated events to Homer. So if you're not familiar with Homer, there's the repo over there. It's basically a project that allows you to collect a lot of information and the actual packets being exchanged or related to the multimedia sessions, in particular related to SIP, which is really useful whenever you want to actually debug or troubleshoot, or even, let's say, rewatch whatever was happening within a session as far as the signaling and the feedback was concerned and things like this. And this is really an excellent component that is already integrated in tools like Asterisk, FreeSwitch, Camaleo, and other tools. And we really wanted to have some kind of integration with Janus itself. And for this, we started writing a new modular kind of approach that is called the Events API, where we have a different kind of plugins that basically can receive events from the core and from the plugins. So the core may say, for instance, I just started a peer connection, these are all the details. Plugins may say the same, I just started a SIP call, I just started a new video room, and things like this. All of these events get to all these event handler plugins, and these plugins can then decide what to do with it. So send it to an external component in order to gather them. You can decide to save it to a database. You can decide to translate this to a CDR. It's really up to you. I mean, the Events API is basically just a mechanism that allows you to do some of the things with these events, and then you decide what you want to do with this. And we have a very simple event handler plugin right now that just handles all these events by shooting them to an external web-based application. And so we started having a very simple loosely-based integration between Homer and Janus, exactly using this. So there is a Homer handler that receives these events and then writes them to a Homer instance so that you can actually then watch exactly what was happening within a Janus-originated SIP session. So the idea is then to have these integrate a bit more in detail later on. This is just a very quick slide instead to talk about some new stuff that we've been working on. And basically, this is like a spawn child of the Janus itself, which is called JATAC, which is a new tool that we've been writing in order to stress WebRTC instances. So whenever you want to check whether or not your, let's say, your WebRTC application can handle 1,000, 2,000, 3,000 kind of peer connections at the same time, you need some ways to stress this. And this is exactly what JATAC aims at being, and we presented it just yesterday at Chicago. Of course, not me because I was here, but another person from Meetecho. So just, we are really close to the conclusion. So I just wanted to give you an idea after this introduction about how Janus works and what it is, an idea of how people are actually using this. And by people, I mean us, of course, but also other companies and people that are actually using this in real world for real use cases. And of course, we use this a lot for our own purposes because, of course, we started writing Janus because we needed something like this ourselves. So we use it a lot for our own web conferencing and webinars platforms. We use it as a WebRTC to SIP gateway. We use it to stream live events, as I was saying, and especially IETF meetings. I'll go this in a minute. But it's probably more interesting in knowing how other people are actually using this in very creative ways. And the fact that Janus is modular and you can use it in different ways really reflects in the different kind of applications that people are involving Janus in. And I'll show you some examples in a few slides. So really very complex, different kind of applications, ranging from standard kind of applications that are used right now to really new stuff that people are coming up with. And the interesting part is also that considering that Janus is modular and so you can write new plugins to extend the Janus functionality, people are actually starting to write tools associated with Janus, whether it's just, let's say, language bindings to use the Janus API from different languages. So for instance, let's say a .NET implementation of the Janus API is available, to make an example, or even third-party plugins to extend the Janus functionality. So new plugins that handle media in creative ways, that handle new transports and things like this. So coming about how we use it ourselves, I was mentioning IETF meetings, and in fact, this is my second time in Buenos Aires because just a few months ago, I don't know if you're aware of this, but the IETF meeting was exactly here in Buenos Aires, in Puerto Madero. And whenever there's an IETF meeting, and there are 3 a year, every year, we always provide, we are the official remote participation providers for the IETF, which means that we stream all the sessions that are there at the IETF, and we allow remote participants to also make presentations, make remote questions, and so on, all based on WebRTC. And the interface that you see there is basically the interface that we have in a control room that allows us to have a complete view of what is happening in every room, because in the IETF there are always 8 sessions in parallel at the same time, which means there are 8 rooms like this that you need to control and make sure that everything works, so that we basically capture a live feed from both the beamer and the camera, like the one that you see over there, and this is translated to a WebRTC feed that people joining the rooms receive. And at the same time, we use instead SIP for the audio instead, because as I said, we want to be able to allow people from SIP endpoints or just the phone to at least listen to whatever is happening and be able also to make questions if WebRTC doesn't work for them. And this interface is pretty cool because just within a browser, we can control whatever is happening. We can move the camera if people walk around and things like this, which is really helpful for us because otherwise we would have to run in all the rooms wherever they are in the venue and make sure that it's pointing to the right point, or maybe even know in real time whenever, for instance, the beamer starts working for some reason and so on, so that we can go and intervene and make sure that everything works. And this is what users see instead. So it's basically just a typical web conferencing application. So you would receive the feedback from the beamer at the center, so you would see exactly what is being projected in the room right now. You have the feed from the camera on one end, and you can also have remote participants popping in there, for instance, whenever there is a remote participant that is actually making a remote presentation to the people in here. There are also other features like chat and things like this. It's not really relevant. If you're interested in having more details on this, there's a link over there that explains how remote participation works in the IETF. And all of this is actually also recorded. And the way that Janus records packets is basically to dump the RTP packets in a structured way so that you can then just later on process these RTP packets, reorder them, and just extract the payloads as if you were a client, basically. You extract the payloads and you save them to a container like a WebM, an MP4, or whatever it is. And the interesting part is that, of course, if you know exactly when a specific media appeared in a specific event, then you have all the metadata that you need to reconstruct the session. So, for instance, my video appeared immediately. Another person's video appeared 10 seconds later. If I have this information, I can then construct a recording out of this to make it so like I build a single video composed of a mosaic of all this information with all the media appearing at exactly the same time, and I have an exact reproduction of whatever was happening in that specific meeting, which is what we do for the IETF specifically. So if you just go over YouTube and you look at all the sessions that the IETF captures of the last few years, you will be able to watch exactly all the sessions that were handled at the IETF meetings, which is about 150 sessions every meeting, more or less. And for all of these, you will see a recording that basically shows a single mosaic version of all of these things with mixed audio and things like this. But it's probably more interesting in seeing how other people are using this rather than just us, because of course we are a bit biased in how you use it. So the first slide that I always like to show, even if it's not really a commercial kind of usage or something, it was just more kind of fun, is how two very popular WebRTC developers that are Neil Stratford and Tim Panton actually use Janus to control and interact with a Parrot drone. So it was one of those drones with wheels and so on and a camera built in. And they implemented basically a new plugin, so a new Janus plugin that would, on one side, implement the SDK to control the drone, and so that they could use then data channels from the browser to say go left, go right, stop, jump, or things like this. And then the video feed from the drone would be received by another small application that was within this component that they built that then would restream the video through Janus, and Janus would restream it back to the user, so that the user could see in real time where the Parrot was watching and things like this, which was really an interesting scenario for us. And there you can see also a live video of actually the Parrot drone working. So you'll see a small demo of how it all worked. And a similar kind of application was also done by the Matrix guys. Matrix is an interesting framework for federated messaging. And they also integrated Janus for some of their demos, and in this case to control a flying drone instead. So they would control a flying drone, receive the video, so that, for instance, then they could record it somewhere and show it at a few venues. And also for this, there are a couple of videos that show this, because thanks to this demo, they also won an award last year. I think it was in Miami, not sure about this. Coming to some, let's say, more regular kind of usages of Janus, this is a really interesting application made by OpenSUSE developers. They basically wanted to create a Hangouts clone based on Janus. And they did exactly that. So you can see there's an interaction, a video interaction between a lot of users who also chat with each other. And all of this is implemented via Janus. So all the chat, all the video, all the audio stuff is all implemented by them exactly this way, which is really kind of a cool usage. I don't know if it works just as well as Hangouts. You will have to try this for yourself. But it's at least a nice alternative that you can also install in your own infrastructure and use, for instance. Then there is this slide that I always like to show with the, with the guys over there. And we'll also see something about this later, so I'll talk about this in a few minutes. So also Silk Server uses Janus in the backend for a few nice things. They'll talk about this later. One thing that we were surprised to hear is that Slack, I think that you all know what Slack is. Slack is actually using Janus for all the audio and I think video also interactions in their backend. So if you are, let's say, a pro user of Slack and you want to communicate with the other people in a room, and you actually do an audio call or a video call or things like this, all of this is actually implemented in the backend using Janus itself. And there are a few blog posts there that actually show, first of all, how this was discovered, because of course it was not a public thing. And then also some of the enhancements that they've made, or they're using Janus in cool way, which really made us proud, because I mean, Slack is really a huge company, and knowing that they chose us for the task was really rewarding. This is instead another application that is made by Lenovo, which is called AirClass. And this is basically an e-learning platform that allows you to join a room, allows a teacher to present a lesson to many students at the same time. And it uses several different plugins of Janus. In particular, it uses the video room and the C plugins in order to have, let's say, again, the possibility, for instance, for mobile or PSTN users to still listen to the lesson or participate in the lesson if they cannot do so via WebRTC, for instance. There are a couple of use cases that are interesting related to applications like Squiggle and Speak.io, which were made basically by the same people, and they were focused on team co-working. So you can pretty much see them as something like a Slack version that existed actually before Slack and was a really cool component. And they also implemented WebRTC support via Janus in both of their tools, which was really cool, especially because they were some of the early adopters of Janus. We tried to help them as much as possible, and then they provided some really great feedback to us, something that we are really grateful to them for. And finally, last but not the least, there's also these Veetings. Veeting is basically a Swiss company that works on enterprise video conferencing communication, and they also use Janus in creative ways. And recently, I also made an interview with their CEO, Fabian Bernard, just to talk with him a bit how they were using Janus and how it was actually helping them a lot and so on. So I encourage you to go over their blog, and if you're interested in reading me talk more about Janus, about all of these kind of things. And this was, of course, not an exhaustive list. This was just a brief list to show you a bit how several people are using Janus in several different ways. There are more companies using it in the wild and so on, so I wouldn't want this presentation to last forever. But in general, let me just conclude by saying that, of course, Janus is cool as it is, but it's not complete. So we need to finalize a few things. We want to work on renegotiation and multi-stream support, simulcasting as well, as I was discussing with Iñaki yesterday. And there are some things that we want to improve. We have some PRs that we want to merge soon enough. And more in particular, I was also discussing the modular events API before, so the possibility of having events generated by the core to be then handled by separate components to allow you to do some interesting things with this. This is also something that we want to push as soon as possible, not only for interaction with Omer, but also for interactions with other cool companies handling statistics and functionality like this. One example being, for instance, callstats.io, which you may know is a very popular company working a lot on live statistics in calls, especially in WebRTC environment. We really want to keep on testing Janus. We've been doing some tests to make sure that everything works as expected, and it seems to be working fine in most cases, but we want to improve things, and testing will help us there. But in general, the best people that can help us improve this is really you. So please feel free to start using this. Write your own, if you write your own basically application using Janus and things like this. If you feel confident, you can also write your own wrappers, plugins, and things like this. I mean, the more people use it, the best we can actually improve, because it means that we have more feedback to work on. And I guess this is all. So I don't know if you have any questions for me, and thanks for your attention, first of all.
Vale. Una pregunta. Cuando hacéis conferencias en el IETF, ¿en inglés?
No, español.
Español. Cuando entra una llamada telefónica en la conferencia, ¿cómo hacéis para entregarle el audio de los demás? Quiero decir, ¿Janus puede mezclar el audio de los demás?
Yeah, the idea, when I made the examples of using the C plugin in order to allow, for instance, PSTN users and things like this, the idea is exactly that you do not use Janus for everything. So the idea is, for instance, in the way that we use it, we use Asterisk as a backend for audio, so we use the ConfBridge application to mix audio in that case. So you use an hybrid approach between the MCU and an SFU approach that you were describing yesterday, for instance. So we use an MCU approach for audio because it makes it easier to interact with other infrastructures like SIP endpoints or PST endpoints and so on, and still allow WebRTC users to talk to each other. And then we instead only use the SFU approach for video, because in that case, if you are a WebRTC endpoint, you get video as well. If you don't, you still have audio, which might be working for you as well. But yeah, in this case, just to answer your question, you of course have to mix in this case, because otherwise you lose pieces of information.
Muchas gracias.
Hola, otra pregunta. Yo que he empezado a utilizar Janus, quería saber si tenéis experiencia o tenéis alguna medida de cuál sería la penalización de utilizar TCP como transporte para el media.
So you mean something like ICE-TCP and things like this? Yeah, we haven't done some specific measurements with respect to ICE-TCP specifically, because in our deployments at least, we typically only resort to TCP when turn is involved. So we typically don't expose ICE-TCP candidates, we just expose UDP candidates for plain RTP, so server reflexive candidates and things like this. And if that doesn't work, then you try to fall back to turn, and in this case, you can try UDP, TCP, or even TLS if that doesn't work. And in general, we don't have many details about how well it works in the wild, even though we use libnice as an iStack, and we do know that it supports ICE-TSP, even though I haven't played with that much a lot. And so I don't have an exact figure on all of this, but in general, my assumption, at least from the few tests that I made myself, is that TCP is not really a viable option in this case, mostly because congestion control can kick in at any time, and so it's really easy to add progressive delay in this case, because with UDP, the packet goes there delayed. It's no big deal. You either retransmit it or you drop it. It's okay. With TCP, you are assured that whatever you send gets on the other hand, no matter when. And if congestion control kicks in and things like this affect the actual communication, this can also result in troubled connectivity, because all the packets get there sooner or later, and you will get very, very much delay. So unless you try to make sure that the WebRTC level kind of congestion control, so it's, for example, via REMB or other messaging kind of feedback, allows you to control the knobs on the publisher side as well, so that you, for instance, say, send us a lower bit rate because you are being delayed for some reason because you do not have enough bandwidth and so on. If you're not careful with this can be very, very problematic. Yeah.
Ayer estuve utilizando la API zip y había un problema con el tema de transcoding. ¿Qué es lo que puedes decirnos acerca de eso?
Yeah, no, something that I forgot to tell during the presentation is that in principle, Janus tries not to do any transcoding at all within Janus itself. And we chose to do that on purpose because, as I was saying at the beginning, we really wanted it to be something that allowed you to put two different technologies in communication with each other as far as the specifics of the signaling protocol mostly were concerned, and the media layers especially. But we try to stay away from transcoding for a couple of different reasons. First of all, because it's usually CPU intensive, and so it can limit the number of sessions that you can have at the same time. And then on the other end, there are several very good tools that are very good exactly at that. So we try usually to establish some kind of a separation of responsibility whenever we try to deploy Janus in some specific infrastructure. So I was mentioning, for instance, how we use Asterisk for the audio conferencing part and things like this. And Asterisk for us has helped, was excellent in providing exactly this feature that was missing within Janus itself. So if you need to bridge a SIP call between the SIP world and the WebRTC world, you can use Janus as a way to very easily wrap all the WebRTC to SIP kind of stuff. And then whenever transcoding is involved, you can reuse components like Asterisk to do the job for you. Of course, this doesn't mean that you cannot implement transcoding, for instance, in your own plugin or modifying the existing plugins to do transcoding as well. But in principle, you need to be aware of the fact that this can add to the burden of the Janus component. So as soon as you start doing audio or even video transcoding and so on, this can greatly limit the things that you can do on a single Janus instance. So it's really better to keep these two features separated typically.
¿En qué lenguaje se escriben los plugins?
Yeah, Janus is completely written in C, and so all the plugins typically need to implement it in that language as well. Even though I think that if you implement a thin layer between the C stack and an actual plugin written in a different language, you can actually write it also in a different language. I'm talking, for instance, with stuff like JNI or JNA for Java, for instance, that would allow you to create a very simple stub in C and then implement all your plugin in Java and things like this. I guess this is probably possible, but we have never done this, and maybe people are doing this out in the wild, I don't know. But it's basically you need to know C to implement a new plugin.
Gracias.